Hello, welcome to Business Statistics. In this lecture, I will talk about comparison of two population means with unknown variance. So we will be using tease statistics for this. So we use tease statistics when the sample size is small. Since we are comparing two populations, we will have two samples, so both should be less than 30. And then, as the title specifies, unknown variance, that means population variance are unknown. So if we have a population variance which is sigma 1 and sigma 2, they are unknown. Suppose we have a population 1 and population 2. So this is population and this is population 2. For population 1, the mean is mu1, and for population 2, the mean is represented by mu2. So to compare two populations, we can either say mu1 is different from mu2, that is mu1 is not equal to mu2, or mu1 is greater than mu2, or the third way is mu1 is less than mu2. So if you see the comparison, one is mu1 is not equal to mu2, it's a two-tail problem because we can test on both sides. So these two are one-tail problem because we can test our hypothesis only on one side. So it's a one-tail. So to compare two populations, it's difficult because a population consists of all the elements. We have to measure all the elements, and population is always fluctuating. So to overcome that problem, we use a sample. So if we take a sample from population 1, we can call it as sample 1. From population 2, if we take a sample, we can call it as sample 2. So this is sample 2. So the statistics about sample 1 can be represented by x1 bar, which is the mean of the sample, and S1 is the standard deviation of the sample 1, and N1 is the sample size. For sample 2, we can represent it by x2 bar, which is the mean of the sample 2. S2 is the standard deviation of the sample 2, and N2 is the sample size of the sample 2. So we can apply t statistics when our N1 is less than 30, that means our sample size is small, and N2 is less than 30. And the other thing which we are saying is sigma 1 and sigma 2 are unknown. That means our population parameters, which is sigma 1 and sigma 2, these two are unknown, so they are kind of unknown. So then we can apply t statistic. So to apply t statistics, we kind of make a couple of assumptions. So one of the assumptions is population is normal. So that is the distribution of each of these populations. For population 1 and population 2, the distributions are normal. And then the second assumption which we will be making is sigma 1 square is equal to sigma 2 square. That is, variances of both the population are equal. So variances are equal for both the populations. So if we have these assumptions, we can apply t statistics. So the next thing is we discussed that we can write these as the difference. So I can write the first one as mu1 minus mu2 not equal to 0. The second one I can write as mu1 minus mu2 greater than 0, and the third one I can write as mu1 minus mu2 less than 0. So if we write those, as we know that x1 bar serves as an estimator for mu1, so we can say x1 bar is an estimator of mu1, and x2 bar is an estimator of mu2. So that means I can write for mu1 x1 bar minus, for mu2 I can write as x2 bar. So it serves as an estimator for mu1 minus mu2. And then if the population is normal, so population 1 is normal, that's what we are saying, and population 2 is normal. So that means the samples which we take, sample 1 should also behave normal and sample 2 should also behave normal. That means our difference, which is x1 bar minus x2 bar, should also behave normal. So if this x1 bar minus x2 bar behaves normal, then we will have a standard deviation of x1 bar minus x2 bar. So x1 bar, so sigma x1 bar minus x2 bar is the standard deviation of the difference, and this is represented by square root of sp square 1 by n1 plus 1 by n2. So this is called pooled variance. And sp square, so we are pooling both the variances, is given by n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. So if you see, this formula is interesting because n1 minus 1 is the degree of freedom for the second sample, n2 minus 1 is the degree of freedom for the second sample. So n1 plus n2 minus 2 is the degree of freedom for both the samples together. So this is for first sample, second sample, and both of them together. So that's how the pooled variance work. So this is mainly the concept of using t-statistics. Again, t-statistics is used when we have n1 less than 30, n2 less than 30, and then sigma 1 and sigma 2, that is population variance, are unknown. So now we will discuss hypothesis testing and confidence interval for t-stat. So hypothesis testing So the first step of the hypothesis testing would be to define hypothesis. So you can recollect that hypothesis testing has null hypothesis. So this is the statistical definition of hypothesis testing. Mu1 minus mu2 equal to 0, and the alternative for this would be mu1 minus mu2 not equal to 0. So this is a two-tailed test. because we can test on both the sides. So the next one is H null mu1 minus mu2 would be greater than 0, greater than or equal to 0. So the alternative would be mu1 minus mu2 less than 0. So the third case would be mu1 minus mu2 less than or equal to 0. So the alternative would be mu1 minus mu2 greater than 0. So these two are one-tailed test because we can test them only on one side. So the next step of hypothesis testing is to compare test statistic with critical value. So again, if we want to use tease statistic t-stat, our n1 should be less than 30, n2 should be less than 30, sigma 1 and sigma 2 are unknown. So the formula for t-stat would be t is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sp square 1 by n1 plus 1 by n2. And then the sp squared, which is the pooled variance, is given by n1 minus 1 s1 squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2. So this is, if you see this is an estimator. This is hypothesized difference. And this is standard error or the standard deviation of the difference. This is pooled variance. So the other thing is we need to compare it to the critical value. So the critical value is for t statistic is given by t alpha over 2 degree of freedom for two tail, and T alpha degree of freedom for one tail. So the degree of freedom here in both the cases is given by n1 plus n2 minus 2. So that's the main concept of critical value, and finally we make conclusions about the hypothesis. And now we can discuss about the confidence interval. So 1 minus alpha multiplied by 100% confidence interval. So alpha is our significance level, as you might know, is given by x1 bar minus x2 bar plus or minus T alpha over 2 degree of freedom square root of SP squared 1 by n1 plus 1 by n2. So again, this whole part is called margin of error. And SP square, if you see, all these can be obtained, like SP square can be obtained from this formula, and then maybe this is an estimator. This is T alpha degree alpha over 2 degree of freedom can be obtained from the table, and this part is the standard error. So everything we have a formula, or we know about everything here. So now that we know the concept of hypothesis testing for T-stat, we will try to solve a problem of hypothesis testing. So suppose I am interested in comparing weight of my two statistics class. So I am comparing weights of two statistics sections. So I have section 1 and section 2. So I am using section 1's mean is mu1 and section 2's mean is mu2, and I am trying to compare them. So my null hypothesis H null would be mu1 minus mu2 equal to 0, and the alternative would be mu1 minus mu2 not equal to 0. So if I have these two cases, the next step is to compare test statistic with critical value. So this comparison I can do if I have a sample. So this is given, so this will be given for your in your problems. So if I take a sample from population 1 and it is represented by x1 bar, which is 160, so the weight of my first section is 160, and I took a sample of 16, and maybe let me erase some of these. Okay, so x1 bar is 160, n1 is 16, and the sample standard deviation S1 is given as 2, and then I take a second sample which is x2 bar, which is 158, n2 is given by 25. So the sample of 25 is taken, and the average is 158, and the sample standard deviation S2 is given as 3, and I am looking for 95% confidence interval. So now I have to compare. So I have a test statistic. So my test statistic T stat formula would be x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sp square 1 by n1 plus 1 by n2. So firstly we have all the values except sp square at this time. So let's calculate sp squared. So sp squared, the formula would be n1 minus 1 s1 squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2. So if we substitute those values, so let me put those values. N1 is 16, minus 1, S1 squared is S1 is 2 squared, plus N2 is 25 minus 1 S2 is 3, so 3 squared divided by N1 is 16, N2 is 25 minus 2. So this we will get, if we calculate this part, we will get 7.077. So we will take that and put it in our t value in our t stat. So for our t stat, x1 bar is 160 minus x2 bar is 158 minus, so mu1 minus mu2 is the hypothesized difference, so hypothesized difference is 0, and then we have sp square, so square root of sp square is 7.077, 1 divided by n1 is 1 by 16 plus 1 by n2 is 25. So if we calculate this, we will get 2.3482. So we have a test statistic value. Now we want to calculate the critical value. So as we know, this is we have to determine whether this problem is a two-tail or a one-tail, and we know it's a two-tail problem because we can disprove on both sides. It has an equal to sign, so we can kind of test on both sides. So the critical value, if it is a two-tail test, so this is a two-tail, is given by T alpha over 2 N1 plus N2 minus 2. So that's the degree of freedom. So to get alpha over 2, they gave us the confidence intervals. So the confidence interval 1 minus alpha would be 0.95. So alpha is 0.05. Alpha over 2 would be 0.025. And the degree of freedom is, so now I'm calculating degree of freedom. N1 is 16 plus N2 is 25 minus 2 should give us 39. So we are looking for the value T 0.025 and 39 from our statistical table. So before we go to our statistical table, we kind of wanted to draw our probability distributions. So let me the normal curve. So if this is our normal distribution, so we are kind of let me erase this thing here. So t value, as you know from the table, will always give you the right side. So this you might know. So this is T alpha over 2 degree of freedom. So in this case we are looking for T 0.025 uh, 39. So this is the positive side. The negative side of this would be t.0 39, but this will be a negative sign. So anything to the left of this is reject H null, to the right of this is reject H null, and anything here is don't reject H null. So okay, so now let's look at our critical value from the table, which is t 0.02539. So here is our statistical table, and we are in t table. So 0.025. So t 0.025, and we go to 39. So this is the 0.025, and we go to 39. So 39 is here. So that same row and column, if we go, so it will be, the value would be 2.0227. So let me see. So this is 2.0227. So let's go back to our work. So this is 2.0227. This is 227. So the value which we have here, this is negative 2.0227, and the value we have here is positive 2.0227. So those are our critical values. So now we take our test statistic value, which is 2.3482, and see where does it lie in the number line. So if this is 0, and I know this is 2.0227, so I will look for 2.34. So it would lie somewhere to the right of this. So this value would be 2.3482. So it lies in the rejection region, so we reject H null. So this is reject. So this is not true. So that means that there is a difference between the weights of the two sections. So that's how we can conclude. So there is reject H null. So there is a difference between the two sections in their weights. So that's the t statistic for two-tail. We can kind of solve one more problem, final problem, and look at how one tail looks. Maybe let's calculate confidence interval before we go to one tail problem. So let's look at confidence interval. So the confidence interval for this problem would be so this is we are doing 95% confidence interval. This is 95. So the confidence interval formula is given by x1 bar minus x2 bar plus or minus T alpha over 2 n1 plus n2 minus 2, and then square root of sp square 1 by n1 plus 1 by n2. So x1 bar would be in this problem 160 minus x2 bar would be 158 plus or minus T alpha over 2 n1 plus n2. So this was in our case we got T 0.025 and 39. So our value was, when we calculated, it was 2.0227, and then our sp square, so square root of our sp square was 7.077, 1 divided by n1 is 16 plus 1 divided by n2 is 25. So if we calculate this, we will kind of get the confidence intervals. So this would be 2. I won't be calculating it, but I would just make a little bit of calculation and explain to you how does confidence interval work. So 2.0227 so maybe I will just leave it here. So you can calculate the confidence interval for this, and if you get both positive values, so the confidence interval for this is, if both are positive, so this is the lower limit or lower bound, lower limit, and this is upper limit. If both are positive, that means our so our hypothesis, we had mu1 minus mu2. So when can the values be positive? So that means if mu1 is larger than mu2, then both are positive. That means mu1 greater than mu2. If both are negative, mu1 is less than mu2. If one is negative and the other one is positive, then mu1 is equal to mu2. So that's how the confidence interval work. You can calculate those values. I have discussed this concept in the comparison of two means with known variance, so you can look through that. But I suggest you to calculate this and observe if both are positive or both are negative, or one is negative and the other one is positive. So now I will try to discuss one tail in this t statistic. So when to use z and t? Firstly, let's z is used when your n1 is greater than 30, n2 is greater than 30, and sigma 1 and sigma 2 are known. So this is when you will use z stat. T is used when n1 is less than 30. So this is greater than or equal to for z. For t, n1 less than 30, n2 less than 30, and sigma 1 and sigma 2 are unknown. So that's when you will use t statistic. So this is the important which you have to remember when to use z and when to use t. So I will go and solve a t statistic one tail problem. So now I am interested in calculating ticket time for McDonald's and Taco Bell. So this is ticket time. So I'm comparing between McDonald's and Taco Bell. And my claim, based on my experience, my claim is McDonald's has less ticket time so this is less time compared to Taco Bell. So again we kind of take our population, and this is represented by mu1, and this is Taco Bell is represented by mu2. So the next step is to take sample. Let me erase this. So our hypothesis would be, so I'm claiming McDonald's has less time, so this is my alternative. So mu1 less than mu2. So my null hypothesis would be mu1 greater than or equal to mu2. So that is mu1 minus mu2 greater than or equal to 0, and then mu1 minus mu2 less than 0. So now the next step is this will be given. We have to compare, let's compare test statistic with critical value. So this will be given. So we take samples from McDonald's and Taco Bell. So when we take a sample from McDonald's, that is x1 bar, the mean is 5 minutes and the standard deviation is 0.5, and our sample size would be 25. So when we take from Taco Bell, it's x2 bar, which is given by the mean time for Taco Bell is 4 minutes, and our samples size would be, our standard deviation is 1, and our sample size which we took is 16. So now if you see, n1 is less than 30, so this is less than 30, n2 is less than 30, and we don't know our sigma 1 and sigma 2 are unknown. So that means we can apply t statistics. So the formula would be t is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sp square 1 by n1 plus 1 by n2. So let's calculate sp square. So the formula for sp square is given by n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. So if we put those values, sp square is equal to n1 is 25 minus 1, s1 square is 0.5 square plus n2 is 16 minus 1, s2 is 1 squared divided by 16 plus 25 minus 2. So this, if we calculate, we get 0.538. So we put 0.538 here. So let me calculate t value now. So the t value x1 bar is given as 5 minus 4 is x2 bar, and mu1 minus mu2 is the hypothesized difference, which is 0, divided by square root of sp square is 0.538, 1 by n1, 1 by n1 is 25 plus 1 by n2 is 16. So this gives us a t value of 4.256. So the next step would be to calculate the critical value. So if you see, for critical value, now we have to determine whether this is a one-tail problem or a two-tail. So we have a greater than or equal to symbol, so it's a one-tail problem. So we do T alpha degree of freedom, which is so our alpha would be, so we have, suppose we want to calculate 95% confidence interval. So 1 minus alpha would be 0.95, so alpha would be alpha is 0.05, and the degree of freedom here is given by n1 plus n2 minus 2. So that is n1 is 25 plus n2 is 16 minus 2, so that would be 39. So we are looking for a value t 0.0539 in our table. So before we move on, we will again draw a normal table for the null hypothesis. So this is, we represent null hypothesis. So we are looking for a t value. So since we have mu1 minus mu2 greater than or equal to 0, we are interested in knowing the lower bound. So this would be our t alpha degree of freedom, that is t 0.0539. So anything above this is do not reject H null. Anything below this, so all this is reject. H null. So as we know our t table, so I will kind of roughly draw a t table maybe. As we know from our t table, we only get the right side. So we only get this side, and this is T alpha degree of freedom. So when we look at the table, we are getting on the right side, so of a normal curve. To get the left side, we have to do negative of T alpha degree of freedom. So we can go to our statistical table and look for t.0539. So I will go to our table and look for t.0539. So this is, if you see this, maybe I will highlight with green. So that's t.05 and 39 is that one. So our value would be this one. So that is 1.6849. so this gives us the positive side. So if we go to our sheet, so this value here, this is 1.6849. so this will be negative 1.6849, negative 1.6849. so in our this hypothesis, null hypothesis curve, this point is negative 1.6849. so now we'll go and look our test statistic value. So our test statistic value is 4.256. so 4.256 would lie somewhere here. Suppose this is so it's above negative 1.6849 if this is 0. so 4.256, so it's in the do not reject region. So our claim mu1 minus mu2, mu1 minus mu2 is greater than 0. so that means if mu1 is McDonald's, this is McDonald's, should be bigger than mu2. so my claim McDonald's has less time to Taco Bell is wrong claim. In fact, McDonald's take more time compared to Taco Bell. So that is how you make conclusion. So this ends our lecture on comparison of two population means with unknown variances. Thank you.